Okay, there are borderline cases. Okay, how to solve the borderline case for p-chart. So we can solve variable sample size, okay, by using individual control limits, or we can use average control limits. Okay, if we use average control limit, you have to be careful on the borderline case. So that what we have discussed last class. Okay. Okay. So these are the formula, basic formula, very basic. The formula is simple: p bar plus 3 square root of p bar 1 minus p bar divided by n. So this is the standard formula. So it says here no standard given, meaning that we have to find what is p values. Okay, in this case, okay, we can estimate the p. I've shown the example last class. Okay, shown that is example. You can find what is the values for p bar. Okay, by getting the number of non-conforming divided by the sample size, which is d over n. Okay, d over n. So if it's constant, so it's going to be simple, straightforward. But the problem is when n is not constant. Okay, so we have discussed this last class. Okay, we have plot the p values. I give you also the assignment for you to exercise this chart. All right. So let me move forward with other type of chart. Okay. The type of chart. What are other type of charts in attribute? Okay. Let me put it this question in chat box. Okay. What are the types of attribute control charts? Okay, what are other type of attribute? We have so far we have discussed only one, which is P chart. Okay, it's correct. Okay, D chart, C chart. Okay, thank you, Khairul. What else? Khairul. Yes. Please, others, please respond to the chat box. What are other type of control chart? Okay, so we have D chart, C chart, and P chart, U chart. Okay, so D and P chart. Okay, and P chart. That's what I want to discuss now. NP chart. Okay, NP chart is a type of non-conforming. Okay, before I go there, okay, I would like to ask another question. What is the difference? What is the difference between non-conforming, or another way we can say that defective? Okay, between non-conforming and non-conformities. Non-conforming, non-conformity. Okay, between non-conforming and non-conformity. Non-conformity. Okay. Non-conforming use P chart. That's correct. Okay. Non-conformities use. Adriana, this is not correct. Non-conformities can be P chart and U chart. No. Non-conformities we use U chart. Not P chart is for non-conforming. So it's not correct to use non-conformities for P chart. P chart is for non-conforming. Okay, please put the difference. What is the difference between non-conforming and non-conformity? Or if it is plural, it's going to be non-conformities. What is non-conforming? What is non-conformities? Non-conformities use C chart, U chart, D chart. Yes, correct. Non-conformities is basically in event bilangan kecacatan. Bilangan kecacatan. Non-conformities defects per unit. That is correct. Okay, defects per unit. Non-conformities is defects. Okay, defects, number of defects. Okay, number of defects. Non-conforming is defective units given number of unit. Okay, number of defective unit given in number of unit. Yes, non-conforming is unit defects. So you may have, for example, 3 non-conformities. Example. Okay, maybe I write it on my screen. Okay. Okay, I just use the screen. You see now the do you see now what I'm sharing, the ebooks, right, on the screen? Okay, good. Okay, let's say I have oranges. Okay. Oh, cannot write, huh? I need a space here. Just conteng kat sini, eh. Let's say I have orange. Oh, how come? Tadi boleh, kan tak boleh. Cannot write, huh? Okay, I try this one now. All right. Okay, let's say you have oranges. Okay, you have orange. 1 orange. 2 orange. 2 oranges, eh? Okay, this orange, kecacatan pada orange mungkin kita katakan ada orange ini berlubang. Okay. So maybe the orange that we inspect, okay, we also have katakan mungkin dah ada kena makan oleh binatang kat sini. Okay. Maybe another type of defects adalah okay, pada orange ni dah pecah. Okay, we can see the cracks there. So you have 3. This is 3 defects. 3 defects on this orange number 1. Okay, orange number 1. Number 1, you have 3 defects. Okay, 3 defects. Orange number 2, maybe no problem. Okay, let's say orange number 2, no problem. Okay, let's say orange number 2 has no problem. Okay, defects. Defects dia adalah 0. Let's say you have another orange, which is number 3. Okay, orange number 3. I should use same color. Okay, orange number 3. Okay, orange number 3. Okay, ada rosak. Okay, you have rosak sini. Okay, rosak merah. Okay. And then mungkin ada rosak juga. Okay, kat sini ada rosak. Kat sini ada rosak. Okay, so in this case, the number of defects, okay, so defects on this one orange number 3 is 4. Okay, defects equal to 4. So the question is, out of these 3 orange, how many defects? Okay, total defects of our sample now is, okay, total defects ataupun another way we can say total non-conformities. Okay, non-conformities. Non-conformities, total number of non-conformities equal to 3 plus 0 plus 0. Okay, 3 plus 0. Okay, plus 4. So altogether you have 7. 7 defects. Okay, 7 defects. Ataupun 7 non-conformities. Okay, so how many non-conforming? Okay, so we can say that number of non-conforming. Sorry, I have to write on this, but tak ada space. Non-conforming. Okay, type of non-conforming. Number of non-conforming will be 2. Okay, 2 units. Okay, non-conforming is referring to the units. So in this case, 3 defect, but non-conforming is 1. Here is okay. This is a good product. This is non-conforming, 1 unit. So we have 2 unit non-conforming. Okay. So if you ask how many non-conformities, here got 3, you got 0, here got 4. If you ask how many defects, got here 3 defects, 0 defect, 4 defects. So if I ask how many defective, then number of defective units is same as number of non-conforming. Okay, so this terminology you must be clear because it can give different meanings. Defective. Okay, kalau kita kata defective maknanya defective units. Defective maknanya defective units, same as non-conforming units. Okay, I hope that that is clear for you. Okay, this is clear. Yeah, move on. Okay, we want to learn about NP chart. Okay, P chart, we know that P stands for proportion. Okay, ataupun nisbah, proportion. So NP, N multiplied by P. N is, we know that N is the number of sample. P is proportion. Okay, number of sample multiplied by proportion, we get the number of non-conforming. Okay, the number of non-conforming. Okay, so this is what we call it NP chart. Okay, NP chart. It is number of non-conforming. Okay, so NP chart. Okay, NP chart. Okay, what is NP chart? Okay, previously we study P chart, now NP chart. Okay, so if we see NP, N is sample size, okay, P is proportion. Okay, so it's going to give a number of non-conforming. Okay, so it is possible to base on the control chart on the number of non-conforming. So NP is actually number of non-conforming. Okay, so this is number of non-conforming. Number of non-conforming. Instead of we use proportion or fraction, we use number of non-conforming. So we use the number directly without the need to get the fraction. Okay, so number of non-conforming, which is NP chart. So we don't have to get the P, we just use the number exactly as it is given, okay, for the number of non-conforming units. Okay, what are the formula used? Okay, these are the formula, very simple. The formula for number of non-conforming chart. So UCL, so meaning that if we plot a chart, okay, if you plot the chart for this, you're going to have okay, a central line, upper control limit, lower control limit. Okay, so the central line will be NP lah. Okay, so upper control limit will be here. Okay, so in the formula we see NP plus 3 square root of NP 1 minus P. So actually here is square root of N, P, and then the other one is 1 minus P. Previously we have almost the same dalam apa ni, dalam P chart kan, dalam P chart you still remember that we have that this is 3 so this is basically macam sigma lah, 3 sigma. Okay, this sigma, but dalam case P chart kita gunakan that square root of, okay, square root of apa, ingat lagi? We have P kan, 1 minus P. Okay, 1 minus P divided by N. Okay, but in this case directly NP, P, so you see the P at the P kat sini macam sama lah, P1 minus P ini N ni, okay, N naik atas sini sebab kita nak dapat numbers the number. Okay, so 3 depan tu is common lah, Y3, because Y3 for 3 standard deviation we can have 99.73%. Okay, we always use, I repeat this again, mungkin for some yang mungkin dah lupa, is normal distribution. Kalau normal distribution lah, but in the case of a typical control chart ni, dia adalah binomial. Okay, but when we say kalau dalam normal distribution lah, dalam normal distribution we have 9 plus minus 3 is referring to, okay, the area which is 99.73% of the area, maknanya proses tu stabil. So the force alarm berlaku when it is outside ni lah, proses stabil sepatutnya. So the possibility of having false alarm using plus minus 3, okay, minus 3 sigma is given by 0.27. Okay, you still remember so kalau dalam X bar chart we have this 0.1 divided by 0.27, you get 370. Okay, so which is, we call it average run length. Okay, average run length. So that's why we always have 3. Okay, always 3 here. This is control limit, upper control limit, lower control limit. Okay, let's move on to see the example. Okay, set up NP control chart. Okay. Okay, I just want to confirm, you see the same what I'm saying now or not? Example 7.2. Yes, okay, good. Okay, so NP chart for the orange juice, concentrate in the same problem 7.1. Okay, let's say now we want to produce NP chart rather than P chart using the same data. Okay, same data. So the only formula, the difference only using different formula. Okay, N is 50. Okay, N is 50, which is given in the earlier example, okay, that we use for P chart. N is for 50. So P, we already got the P values. P bar we already calculated. Okay, P bar we already calculated, which is given by this one. And the others are very simple. And in this formula, just put this number, and 50 P bar is 0.2313. Okay, plus 3, and the N is 50. This is P bar. This is 1 minus P bar. So you are ready to get upper control limit. Okay, lower control limit, just change the symbol here to become minus, and then you get this value. Okay, so as simple as that. Okay, P chart is very simple, and P chart is very simple. And then what you plot, okay, maybe confusion is when what you want to know what to plot. Okay, what to plot on the chart. Okay, what you're plotting is number of non-conforming units. Okay, let me go to the data. Okay, this data. Okay, this data that we are referring. Okay, this is can. Okay, what is the orange juice? It's the same, right? Yeah, this one. Orange juice data. Okay, so here we have P values, but in NP chart, what we do is, okay, I just sketch here again. Okay, you have, let's say you have developed the control limits. Okay, so the line here will be NP. Okay, so the upper control limit for NP, lower control limit. So what are you plotting? We plot these values. Okay, number of non-conforming. In this case, they call it D. So actually, this is NP. Okay, same thing, NP. So you will be plotting all these values. Okay, all these value. Plot. Okay, plot on the chart. Okay, very simple. We don't have to calculate the P, directly plot. For example, 9, plot the 9. Okay, the 6, plot the number 6. Okay, 12, plot number 12. Itu saja. Okay, because what we plot is the NP. Okay, NP, what is NP? Number of non-conforming unit. Okay, so this is NP chart, and then okay, NP chart. So okay, what happened if there is variable size? Okay, same situation that when we have P, yeah? We have P chart. The case of NP chart, when there is variable size, okay, let's say, okay, variable sample size, okay, variable with control limit. Here we need to determine, okay, for each individual sample. Okay, for each individual sample. Okay, so this formula will be used. Okay, where, okay, in this case, Okay, in this case, is talking about P chart. Okay, for NP chart, okay, NP chart is used for fixed sample size. Okay, not for, sorry, this is talking about in general. Okay, so this given here is P chart. P chart is okay to use for variable sample size, but not for NP. Okay, not for NP. NP chart is normally we use is fixed sample size. Okay, you don't see any example here showing the NP chart used for variable sample size. Okay, so again, this is P chart. Okay, it's showing here is P chart, not NP chart. Okay, so this is P chart. Okay, P chart. So do we have variable sample size for NP? We don't use NP for variable sample size. Okay, better use P chart when there is variable sample size. Okay. I hope you are clear. If you are given variable sample size, use P chart. NP chart, we don't use it for variable sample size. Okay, let me move to another type of chart. We still have C chart and U chart. Okay. Okay, this is, we call it non-conformities. I was explained earlier. Okay. I explained this earlier, non-conformities or defects. Okay, what type of chart we use here? We use C chart, we use U chart, or we use demerit chart. Okay, demerit chart. Okay, in fact, you can use this demerit, for example, to monitor traffic offense. Okay, for example, later on you jadi polis lah, future polis. Ataupun you give consultation to police how to monitor how serious is traffic in Malaysia. We can use demerit. Okay, kalau langgar traffic light, berapa point? Kalau apa ni speeding, okay, berapa point and so on. Okay, we can use demerit because different kesalahan has different weightage, okay, different seriousness. Okay. So there are many possibilities of using this chart, not only in manufacturing. Last class I mentioned can be used in construction. Okay. Even in banking, people are using control chart to monitor how much mistake they have done. Is it normal mistake or is it assignable mistakes? Okay. Okay, let's see the procedure here. Okay. Okay. This is it says a standard given. Basically, we know what is C value, what is the C values lah. Okay, kalau maksudnya C is given, but most of time the C is not given. Okay, most of time C is not given. So we use this formula. Okay, use this formula. So this is the formula that we use for C chart, or we call it count of non-conformities. What is C? C means count of non-conformities. Okay. Count of non-conformities. Okay. So another way, number of defects lah. Okay. Count of non-conformities or count of defects. The count of defects. Okay, for example, you send a document for a typist to do it. You can count how many mistakes he made on one page of paper. Okay, we can use this simple control chart. Okay, C plus 3. Okay, Y3 I explained already, to get it 99.73 within the control limit, within the control limit. So square root of C. Okay, so C bar plus 3 square root of C bar. Very simple. Okay, so if it is lower control limit, you just change this symbol, become negative. Itu saja. Okay, the rest are still the same. And normally, the lower control limit is not important as in P chart. Even in P chart pun lower control limit not important. Because why? Sebenarnya when the count is lower, mean that process is better. We are concerning only upper control limit because that is where we want to monitor is not exceed the control limit, upper control limit, not to exceed lower control limit because the lower, maybe I can explain here. Let's say you have C chart. Okay, C chart. What you are plotting is value of C. Okay, value of C that you plot. Okay, C chart. When we say C chart, what we plot inside is C values. When we say X bar chart, what we plot inside is X bar values. Okay, so inside here, plot C. Plot C. Okay, we plot C. How many count? So, if you have upper control limit kat sini, and you have C bar kat sini, you have lower control limit kat sini. Let's say you have one value, suddenly it is here. Okay, so this value, you cannot say it is due to assignable cost unless you know that it's assignable cost. But most of time, this value is showing good performance. Okay, good performance. Why? Because low count of non-conformities. Okay, good performance. Don't confuse this with X bar chart. So this is good performance. So why you need to have lower control limit? I said before, lower control limit is not so critical for attribute control chart. We just want to know why it's so good and not why it is bad. Why C is low. Okay, good performance. So we put this, if you want to use the lower control limit, we want to see why is good performance. Okay, so that we can repeat. Why? So that you can repeat, okay, similar good performance for future production. So you want to know the reason why it is so good, not so good here, meaning that lower number of C, so that your future production will also have lower C value. But if we have somewhere here, this is above control limit, we want to see why is too high, why is it is bad performance. So you remove the root cause of this poor performance. Okay, root cause of this poor performance, because the C value above control limit. Poor performance. Okay. So the same situation for P chart and P chart. Okay, the same case. So when it is above control limit, it is poor performance. We want to know why. Okay, when we want to know why we want to eliminate the root cause. Okay, to eliminate the cause. How you eliminate the cause? You have to go to the machine and make improvement. Okay, or maybe need to replace certain component in the machine because it's producing too many defects. But when it is below lower control limit, it shows good performance. Okay, it's not showing bad, it's showing good performance because low C. Okay, so we want to know why it is so good, why we need to repeat this good performance. Okay, so the meaning has the values above control limit and below control limit has different interpretation. Okay, any question on this? But when we use X bar chart, okay, any point beyond upper control limit or lower control limit, they are showing potential of having assignable cost. Okay, when we use X bar chart, okay, which is variable control chart, whenever observation point is outside control limit, which is above upper control limit, or below lower control limit, it suggests to us that the process is having problem. We need to identify that problem to remove. But in the case of attribute control chart, point below lower control limit indicate good performance. Okay, indicate good performance. So I hope that is clear. If you have any question, please let me know. Okay. Right, no question. I see no question on the chat. Or you can open your mic. All right. So let's see example for C chart. In non-conformities in printed circuit board. Okay. This table 7.7 present the number of non-conformities observed in 26 successive sample of 100 printed circuit board. Okay, note that the reason of convenience, okay, the inspection unit is defined as 100 board. Okay, set up a C. Okay, another things that we are concerned in, or what we are using in C chart is we call it inspected unit. Okay, the inspection unit. Okay, what is inspection unit? Inspection unit can be, in this case, is 100 board. 100 board is considered as inspection unit. We can also have 1 dozen. There may be 1 box. Okay, for example, we want to do inspection for paper, A4 paper. Okay, we are producing paper. We put it in the rim of the paper. Inside the paper, you may have maybe 200 sheet of papers. Okay, so let's say you want to do inspection of this paper in this package. Okay, so this is, we call it 1 inspected unit. Inside this unit, you may have 200 pages of papers. Okay, 1 inspected unit. You may also have, like for example, you are working in a company producing carpets. Okay, using carpet. Okay, the company is producing carpet. So how do you define the inspector unit for a carpet? Okay, or maybe sheet metals. Okay, you have sheet metals. Okay, you want to do inspection for sheet metals. Okay. Okay, your sheet metals, maybe you have, okay, I put it carpet lah. Everybody knows what carpet is. Simple. You have long carpets. So this carpet may be the size of this carpet 3 meters. Okay, 3 meter. Okay, how many unit you inspect? So this is, you call it 1 inspected unit. 1 inspected unit. So you may be inspecting this carpet. You want to find any mistake in this carpet, any defects. Maybe somewhere here is not well, made, and then maybe they got some hole, and maybe they got extra benang kat situ. Okay, mungkin the corner is not good. Okay, so the whole carpet is 1 inspected unit. Ataupun you do in construction, okay, 1 unit of house. Okay, you want to find how many defects in that house. Okay, maybe you are producing 50 unit of terrace house. It looks similar, the house, but the inspected unit will be 1 unit of house. And then you go and find where is the crack, where is improper finishing, and so on. Okay, in this example, we have printed circuit board, and sample number is given here. You have 20, I think given 26, right? So number of non-conformities, in this case, 100 unit. Okay, 100, maybe in one box of, okay, in that 1 box, they have 100 PCB. Okay, got 100 PCB. So for what we call inspected unit, okay, in this case it will be equal to 1. Okay, inspected unit. Walaupun dalam tu ada 100, okay, this is what we define as inspected unit. Okay, make sure you understand this, otherwise you get confused with different type of chart. But for C chart, we consider as n equal to 1 is inspected unit. Okay, we define this inspected unit. Okay, walaupun dalam tu ada 100. Okay, so these are you found that within the 100 tu ada 21, ada 24 and so on. Okay, sampailah 26. So how do you prepare the control chart? Okay, so just very simple. We just add all the non-conformities, which is 516. The total of non-conformity 516 divided by 26 here. Okay, divide by 26. Okay, 26 subgroup. Okay, so on average you have 19.83. And then upper control limit, lower control limit is straightforward. Just put it in the formula. Okay, and then you get this value and you are ready to produce the control chart. Okay, these are the control chart. The control chart for non-conformities. Okay, control chart for non-conformities. Okay, so and then you plot. What you plot here? You plot C values. Okay, plot the C inside. And then you compare now. We found out that 1 is outside. Okay, 1 is outside. So this one, they got a good result, but they found out inspection error. Okay, no problem, inspection error. But normally, as I say, any values below lower control limit shows a good performance. Okay, not a problem to the process. Okay, so let me move on. Okay, so if you do revision, same case as P chart, we can also do revision. Okay, in this case is you continue collecting the data, okay, 27, 28 and so on. So how do you compare this performance? We can compare with the revised control chart, okay, revised control limits. Okay, but we need to know, before we revise, make sure that we know that the points outside upper control limit is coming from assignable cost. Okay, so even you can further use cause and effect diagram, okay, to identify the root cause of that point outside control limit, especially the upper control limit. Okay, so in this case, it shows that you can use this defects in PCB. Okay, why you get that defects? So you can do the brainstorming. Okay, it could be raw material, it could be shoulder process inspection after using the control chart. Okay, you identify the problem with control chart, and then you move on to understanding better about the problem of process outside control limit. Okay, we have studied this fishbone diagram. Okay, so fishbone diagram can assist us to identify the root cause of the defects. Okay, apa penyebab defects dalam printed circuit board? Okay, so okay, another chart that you can use is, we call it U chart. Okay, U chart. Okay, U chart is really is like P chart. Okay, it is like P chart, but in this case we are taking the ratio. Okay, the ratio of C over N. Okay, C over N. Okay, so the ratio of C over N. Okay, so U chart is given by this formula. It's also counting non-conformities. Okay, So U, okay, U is equal C over N. We know that C is count of non-conformities, N is the size, sample size. Okay? The sample size that we use for every time we take the sample. Contoh yang tadi dalam PCB tadi dalam PCB tadi kita ada satu kotak. Dalam kotak tu ada 100 PCB. To 100. If you use C chart, okay, if you use C chart, in C chart, your N will be equal to 1. What we call it inspected unit. But if you use, okay, if you use U chart, okay, since U is the ratio, okay, so the N will be 100. Okay, N will be 100. So because you have the count of non-conformities, divide by how many units you inspected. Okay, let's see example. Okay, the supply of engineering group monitor shipment of material through company. Error, either deliver material or company document are tracked weekly. Each week, 50 randomly selected shipment examined. Okay, so it's given in table 710. Okay, you see here in table 710. Okay, these are the data given. Okay, these are the data given. The data given here, sample size is 50. Okay, every time inspection is 50. Number of non-conformities, okay, as shown here. And then now we have to take U. Okay, as I say, U is the ratio. U is the ratio. Okay, U equal to C over N. Okay, where is C? C is here. It's shown as XI in this case. This is actually C. Okay, this is N. Okay, the case of PCB earlier yang kita bincang tadi adalah 100 kan. Dalam case ni, di for example, dia adalah 50. So, when you have 2 kat sini, jadi maknanya 2 divide by 50. You get 0.04. This is what you get. Macam kira P lah. Kita kira P kan. Okay, dalam case ini, we are counting the defects. Okay. So, the second one, 3. Okay, 3 divide by 50. Okay, you get 0.06 and so on. Okay. So, and then you just plot. What you plot here? What you plot here is U values. Okay. So, what you plot is plot U values. Okay, the value of U inside this. Okay. So, this central line is U bar. Okay. What you plot is U. Okay. So this you get from the formula. This also get the formula. So what is the formula for U chart? Okay, the formula for U chart. Okay, it is given here. Okay, the central line is summation of U divided by how many subgroup you have, the U bar. And the control limit is given by this formula. Okay, upper control limit equal to U bar, which is central line, plus, as usual, we use 3 sigma. The sigma here is given by U bar divided by N. Okay, lower control limit, just change the symbol of, this notation here. I mean the symbol plus become negative. Okay, the rest are the same. Okay, 1 divided by n. Okay, so I think we have done all this contour chart, and time is also running out. I have only one more chart to discuss, which is D chart. Okay, I will do that next class. Okay, this chart apa ni yang G and H tu kita tak cover. G and H we don't cover in this class. Okay, when there is variable sample size, same thing that we need to address this. We have to do individual control limit based on the individual n, same as what we did for P chart. Kalau ada case variable sample size. Okay, the next class I will cover demerit system. Okay, where we can use demerit control chart to monitor different seriousness of defects. Right, I will put you a few questions for you to exercise on C chart, U chart, and NP chart. Okay, is there any question you want to ask before we exit for today? Any question? Alright. Siapa yang ada urusan dia boleh exit. Okay, let me answer this question. Somebody asked a question. Saya still confused bila nak guna U chart. Okay, from Muhammad. From Muhammad. Okay, Muhammad, this is a good question. Okay, bila nak guna. So this is common. Common confusion. Okay, when you are not told, you are not apa ni, tak ada tips apa tak diberitahu. Memang biasanya kita tak bagi tahu what chart to use. So you need to make a correct decision. Okay, what type of chart based on information given. Okay. So macam mana kita nak jam bahawa itu adalah U chart. Okay, first adalah okay, let me put my power dulu sekejap. Okay. Chart adalah a U chart. A U chart is U chart. Okay, U chart adalah for non-conformities. Okay, U chart is for non-conformities. Non-conformity. Okay, ataupun for defects. Okay, for non-conformity ataupun kalau plural it will be non-conformities lah. Okay, ataupun for defects. Okay, lepas tu saya terang at the beginning that you must have clear understanding what is defects and what is defective. Okay, this is defects. Okay, so kita pada mana ni? On. Okay, defects. Defects. So jadi kalau kita tahu ia adalah maksudnya problem tersebut berkaitan dengan conformity, ataupun conformities. Okay, dia mesti sama ada U chart ataupun C chart. Okay, so C chart seperti yang saya kata, C chart ini biasanya dia akan ada inspected unit. Apa maksud inspected unit? Inspected unit ni boleh jadi satu kotak, satu dozen, satu rumah, satu keping yang besar, macam tu. Jadi U chart ini biasanya dia ada nilai N yang bukannya satu. Okay, U chart. Sebab U adalah C divided by N. Okay, so N bagi C chart normally is a big size. Okay, kalau untuk C chart, N-nya adalah equal to 1. Okay, we call it inspected unit. Okay, inspector. Jadi kalau salah pilih chart, semua salah lah. We cannot help lah. Okay, any more question please? Is it clear, Muhammad? Alright, kalau clear itu saja untuk hari ini. Okay. Thank you very
Betul.
much. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Betul.
Right. Ada nak tanya soalan?
Bukan berkenaan ni, berkenaan group assignment boleh?
Boleh?
Okay, sekejap dalam apa? Outline ke apa? Group assignment tu.
Guideline tu.
Guideline tu. Yang problem investigated tu, yang ni saya faham lah.
Ya.
Problem investigated tu tajuk kita yang kita pilih, betul tak?
Ya.
Okay, lepas tu objective and scope tu cerita objektif apa yang kita kena buat dalam bidang tajuk kita tu.
Ya.
Macam contoh kalau saya pilih Six Sigma for process improvement, maksudnya scope tu adalah dalam manufacturing ke construction ke, betul?
Scope tu sebab dalam Six Sigma tu kan banyak perkara boleh bincangkan kan. Kalau you katakan you punya objektif adalah to compare application of Six Sigma implementation in two companies. Mungkin ada orang buat, company A dia buat, company B dia buat kan. Sekarang ni you baca report dia, you nak banding bagaimana mereka menggunakan perbezaan kan. So you punya scope, you kata the scope will be limited to case studies yang you select. Adalah dua tu. Perbandingan boleh jadi macam-macam perbandingan. Scope ini adalah limit tau. Limitation. Limit, macam mana you nak limitkan boundary of your coverage of your case study. So you katakan perbandingan is limited to company A and company B only.
Okay. Lepas tu source of data, paper yang kita ambil tu lah kan?
Source of data tu maknanya you bagi tahu that whatever discussion, contohnya dalam kajian kamu tu ada menunjukkan bagaimana mereka menggunakan control chart. You akan tunjuk control chart yang dipakai kan, tapi you kena bagi tahu these are coming from the source reference tadi lah yang you rujuk tu. Sebab you tak pergi ke kilang nak collect data. Kecuali ada yang pergi ke kilang lah, kalau dapat daripada, katakan you dapatkan data daripada kilang, katakan. Mungkin dah ada dapat daripada mana-mana. You beritahu lah data is coming from kilang ABC katakan, ataupun from internet macam tu. Mungkin dalam laporan yang you nak buat tu mungkin tak tunjuk data. Jadi kata okay, you pinjam data dari tempat lain. Nak demonstratekan penggunaan teknik Six Sigma tu.
So paper tu lebih daripada satu ke?
Kalau nak, saya minta jangan buat satu. Kalau perbandingan, memang saya encourage buat perbandingan. Sebab bila buat perbandingan, you will be your own work. Okay, so maknanya dalam guideline tu saya kata reference minimum kena ada 4 rujukan. 4 rujukan ni mungkin dari paper, mungkin daripada internet source ataupun laporan-laporan yang terdahulu. 4 laporan. You ada 4 orang kan. Jadi it's not heavy sebenarnya. Kalau seorang fokus one laporan and then cuba bandingkan bagaimana different people that have buat kajian. Mungkin kajian yang dari paper tu dia buat kajian sebenar, dia pergi kilang, dia bawa masuk lab dan sebagainya. Tapi oleh kerana you are now in pandemic, you cannot go to the lab, you cannot go to industry easily to collect data. So, jadi we want you to compare works that others have done. Okay, perbandingan, kesamaan, contohnya Six Sigma in company A bandingkan Six Sigma in company B.
Itu seorang je buat ke? Yang contoh, yang bezakan antara company A dengan company B, itu seorang je?
Seorang masuk macam mana?
Seorang je ke yang buat, yang bandingkan antara A dengan B? Lepas tu seorang lain buat yang lain ke macam mana?
Oh, okay. You in a group. Okay. Dalam group tu you agih lah. Sebab dalam Six Sigma tu banyak perkara. Jadi, you punya perbandingan itu is as a group. Assignment is group. Jadi you mungkin menggunakan sumber lebih daripada satu. Katakan you punya case study yang you jumpa tu simple sangat. You ambil perbandingan untuk company lain pula. Jadi kalau scope of the perbandingan tu case study A dengan case study B adalah kecil, tidak memberi satu ulasan yang baik, mungkin you perlu ambil tambahan case study. Cari paper lain pula ataupun report lain pula untuk buat bandingan bagaimana mereka menggunakan. Contohnya, company A pakai X-bar chart, company B pakai Q-sum chart. And then you boleh buat banding yang mana lebih efektif ataupun kedua-dua yang sama efektif. And then you boleh komen, dia sepatutnya guna EWMA chart. Kenapa? You cadang. Faham tak? Jadi you buat perbandingan, tengok kelemahan ataupun limitation yang ada dan cadangan. What is your proposal? You akan identify, okay? You kata, why not dia pakai EWMA? It's better. You study dalam kelas, kata lebih sensitif. Di situlah saya nak tengok you punya ideanya.
Oh, yang EWMA cat semua tu itu dikira bawah productivity quality tool lah kan?
Di bawah quality tools lah.
Okay. Key finding tu just apa yang bezanya lah. Yang
I would like to see your comment tau, kesesuaian contoh chart. Macam tadi ada seorang tanya, Muhammad tanya kan, where to use U chart and C chart. Mungkin you kata, why not this company guna U chart? Dia sepatutnya guna U chart je, which is more suitable compared to C chart katanya. And then you cadang lah, you kata your group cadang a better chart for this problem. But the earlier study did not use that. You faham apa maksud?
Okay.
You baca apa yang ada sekarang, you banding, and then you beri cadangan pembaikan. Saya nak tengok macam tu bentuknya.
Okay.
Sebab biasanya memang akan ada room for improvement. Whatever people have done before. Okay, mungkin you katakan, okay, kajian sebelum ni tidak menggunakan fishbone diagram. And then you cadangkan, okay, masalah ini perlu diteliti menggunakan fishbone diagram. And then you bagilah contoh fishbone diagram yang boleh dipakai lah seperti berikut. Faham tak?
Okay.
So kena ada kreativiti lah sikit apabila kita baca kerja lepas dan kita komen untuk penambahbaikan.
So dia segmen ni macam komen je lah sebenarnya. Kita tengok orang punya.
Yes, komen apa kelemahan dia, apa yang dia tidak buat, mungkin you rasa dia sepatutnya buat. Kalau dia bagus, komen lah bagus. Kenapa dia bagus? Laporan ini bagus kerana dia menunjukkan dengan jelas. Okay, apa yang bagus? You kena tunjuklah bagus yang di mana. Di mana you kata, buat perbandingan ini menambahkan kefahaman kamu. Kefahaman apa yang you lebih faham? Mungkin apabila buat perbandingan laporan itu, you kata you sekarang ni lebih faham bagaimana sebenarnya Six Sigma digunakan dalam menyelesaikan masalah industri. Okay, you bagi contoh lah yang digunakan, katakan menggunakan kajian tersebut di kilang tayar. Okay, D-nya macam mana, M-nya macam mana, A-nya macam mana, I-nya macam mana. And then ada company you kata pakai juga Six Sigma tapi susah nak faham kerana tak ada apa, tak ada ini, tak ada ini, tak ada dan sebagainya. Faham tak?
Boleh faham.
Sebab apabila you membandingkan, you will improve your understanding. Okay? Kalau you just ambil satu laporan yang orang dah buat, apa you nak komen? Satu je ada kan? Itu yang saya menekankan. It is highly recommend that you use at least 2 previous work, you make comparison. Okay, kalau you pilih tajuk tu lah.
Kalau macam contoh yang Six Sigma for process improvement tu, maksudnya kita compare jugalah antara improvement antara case A dengan case B punya tu.
Yes, macam tu. Six Sigma for process improvement in company A and company B. Tajuk yang saya bagi tu umum, you boleh modify kesesuaian lah. Mungkin kata comparison in two companies, comparison of Six Sigma for quality improvement in company A and company B. Okay?
Okay dah.
Soalan lagi? Saya dah buka link untuk submission untuk you nak submit tajuk dan scope dan apa yang saya minta tu lah dalam e-learning. So by next week you have to upload lah. That will be 2% marks. So you have to get together in the group and make discussion. Okay? Apa soalan?
Saya lagi yang untuk yang group project internnya report tu, Apa
Ya.
je content dia? Kita perlu ada tajuk, skop dan
Saya ada tulis dalam guideline tu, you kena ada tajuk, you kena bagi tahu ya ahli-ahli, siapa jadi ketua, dan apa sumber rujukan yang you akan gunakan. Maknanya sekarang ni you kena identify, you nak rujuk ke mana. From paper mana, from laporan mana, from internet mana, ataupun YouTube mana. Maknanya you have search your case that you would like to go deeper lah. Tapi kalau kemudian nak ubah, kadang-kadang you dapati you jumpa sumber rujukan yang lebih baik, tak apa, you mention lah. Asalnya you guna rujukan ini, tapi oleh kerana you jumpa yang lebih baik masa you buat tu, okay, penambahan sumber rujukan itu you maklum lah masa you dalam PowerPoint nanti.
okay. Oh, betul. Terima kasih, betul.
Okay, sama. Ada lagi? Soalan lain? Okay, kalau tak ada itu saja. So, that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, betul.
Sama.